Uh, Thank you for giving me an opportunity to talk. Um, Holidays are here and you're still here. That's a big thing for me. So thank you so much for the opportunity here. I'm Sunil Rathod. Let's. I'm going to talk about Azure SignalR service. The SignalR as a technology we might have come across in various settings because it's there since more than a decade now. Um, it has come a long way. We'll talk about its history as well. Uh, but yeah, that would be the topic for the day. A little bit about me. Yeah, I love solving business problems. I have worked in different verticals like finance, healthcare, e-commerce. Now I'm in the agriculture space. Uh, I thrive on collaborative teams. I like I have the people first mindset. I love meeting people and, working together with them, sharing the energy, uh, the ups and downs in the project. It's all fun. And yeah, can't live without learning. This is fortunately that's our job as well. So that's great. And yeah, love spending time with my family and friends. And that's why we see like at least 60% of the room is today my friends, like here sitting. So that's great. Uh, been 16 years in the industry. Yeah, it's been a long time. So any presentation can't start in today's day, in today's world without GPT or chat GPT or AI stuff coming into. So this is what AI, the Bing chat brought me with this, it gave me this image when I said, hey, real time, how do we navigate the real time communications? So when we say real time communication, the need of real time communications has never been more than what it is in today's world. You talk about stock market, real-time communication. Talk about an aeroplane flying. You need, you want to see, track the aeroplane. You just Google it out. You see the current location, the real-time locations. The baby sleeping in another bedroom. You want, nowadays people put a camera to watch to see the real-time feed. Make sure the baby cries. You go there and take care of the baby. So there are a lot of ways we can see the real life examples of real time communication today, and the need of it has increased a lot. Some facts here as we start in. These are again given by uh, Chat GPT. What it thinks is that the real-time chat application, like 80% of the smart users regularly use their messaging apps for instant communication. There are there's data that at least 30% of improvement has been seen uh, in the data-driven decision making when we have live dashboards capabilities. So we can in our technology world itself, we have seen that observability is big thing today nowadays, right? The live dashboarding is the need. The need is increasing on that front, and we've seen that there are significant improvements. Online gaming is another industry where the real-time multiplayer experience is also something is projected to be increasing in the industry by 2025 here. Collaborative tools, since COVID, there is a big jump into uh, collaborative capabilities, right? Editing capabilities. I'm sure in the medical solutions as well, you might have some collaborative tools like real-time collaboration tools where uh, people sit remotely and collaborate with each other. So that it says that the 40% increase in productivity has been seen with the use of those tools. IoT as well says like there is 20% improvement in the operational efficiency in the IoT when it comes to real-time communication among the devices. In the real-time communication space, based on the case and scenarios, there are different technologies available. Some of them are competitors. Azure SignalR service is built on top of WebSockets, and then PubNub is of PubNub and Pusher offer somewhat similar capabilities versus what is being offered by Amazon SNS and MQTT. It's a little bit different, but that is in real-time communication space. So Azure SignalR service in this real-time ecosystem is known for these capabilities, or provides these features. Basically gives you the scalability. We'll see in the presentation as we go forward how it helps with the scalability and how it has changed over the period of time. And it has cross-platform support, better integration with Azure services so that it can connect well in the ecosystem of Azure, and then allow you to form creative solutions. It's easier than what it was before, in terms of its deployment, in terms of its usage, the way you set it up. There's a lot. It is a lot easier now compared to what it was before. Real-time broadcasting capabilities and serverless SignalR and presence awareness. These are some of the features that we'll look into as well. Like the serverless SignalR is what we'll look into. So that is what Azure SignalR service offers. Before going to Azure SignalR service, let's just understand what SignalR as a technology is. I think some of us might have an opportunity to work with it in past. SignalR is nothing but a library which allows us to have the real-time communication built into our applications. So it gives you, the methods to call in, the library framework code to basically use the WebSockets as the underlying technology, and have the bidirectional communication set between the client and the server. If you want to do it with the web technology like the WebSocket, it will be harder for you to do it, right? So this library makes it easier for you to work with and enable that bidirectional communication using WebSocket. So primarily it uses WebSockets, but then it has failback mechanisms in it. Like if for some reason WebSocket is not available, then it falls back to server-sent events. And if that is not available, it falls back to long polling mechanisms to basically make the communication possible between the server and the client. So overall, it allows you to have those real-time communications, making it simple to use. That's the offering of SignalR as a technology. Before we jump into this, I just wanted to go over some terms that are used in this SignalR world. Hub is basically, imagine it as a class which sits on your server side, and all your clients connect with this hub. Right? It allows, and the hub is what communicates with the clients. So that's what hub is. Connection is a connection between a client and a server, and client is nothing but your phones. It could be devices, it could be your laptops or browsers trying to communicate with a server, right? Transport mechanisms could be, as I said, the WebSockets, server-sent events, long polling. These are some of the mechanisms, underlying transport mechanism on which the technology is built. In SignalR, as I said, the server can communicate with client, and the clients can also communicate with server. If the server wants to communicate with a set of clients, that is also possible, and that is called groups. So with the help of groups, basically you'd be able to, let's say you want to broadcast a message to a set of people which is different than the others. You would be able to do that at real time. Persistent connection is a term where a client and a server, when they connect over WebSocket, the connection is persistent. So in HTTP, the connection is not persistent, right? Like you make a call and you get the response done, right? Again, when you make the call next time, you make a call, you get the response. But here, the connection stays open. That's what the persistent connection is. So through that connection, there is a constant communication happening between the client and the server. So that's why persistent connection. And WebSocket is what makes it possible. Yeah, and then the message that you sent across, scaling, we all know what it is, but in this space, it has different places where you need to scale. You need to scale at the server side, you need to scale at the client side. We'll look at that here real quick, but then in this space, the scaling has a different place at different um, sides of your solution. So historically, if you look at how we had developed the SignalR solutions in self-hosted cases, is like you have server, as I was saying, there's hub sitting, SignalR hub sitting on the server, the library which allows you to connect with the clients, it's sitting on the server. That forms a direct persistent connection with the web client. So you have client-side libraries as well. So for example, a phone or website where you have JavaScript enabled, your JavaScript libraries would be able to make a call to the server and then form a persistent connection over WebSocket. So likewise, your phones will have, let's say if you have Android, they have native Android support as well. Those libraries will allow you to basically connect with the server and you form the connectivity. And then once the connectivity is formed, the server would be able to send the messages back to the client, or the client can send messages back to the server. So the problem in this model is scale. As we go forward, historically, we have seen that what happens is like as if your client increases, because your client is increasing, you try to scale at the server as well. But then the problem here is that because of high number of connections and the way the WebSocket technology works, it's harder for the server to keep up with the number increase number in the client side. So there would be the server load, there would be limited number of connections that would be, so some of the clients will not be able to connect. And because of that, you will have a less interesting customer experience, basically.
I think that has to do with because the connections are persistent.
Yes.
Synchronous in nature rather than.
Yes, they are like formed persistent connections. There are limited availability of it. That is the reason you would see that many new clients will not be able to make new connections at the same time. We have also seen like there is a drop in the connections as well, like with the existing clients. So those are some of the issues that we've seen in the past with these kind of solutions. If you look at SignalR history, before we go to Azure SignalR service, we look at the history a little bit. It was introduced in 2011. It was supported by the community throughout like 2014. And in 2018, it was adapted by ASP.NET Core. So there are two versions that exist today, a .NET version and the Core version. So the core version was adopted in 2018 here and made it that allowed it to become cross-platform. So you could have server-side code residing on a Linux machine, iOS machine, Windows machine, and also client-side. The cross client-side platforms were also increased. We'll look into that in some of the platforms as we go forward here. And after that, it was offered as a service, platform as a service via the Azure, where it simplified the deployment and scaling of this technology. So right here, you see in the previous slide, we saw that there were some scaling issues. So all those issues were solved and offered via the PaaS offering. So in this slide, you can see that self-hosted, which we just spoke, where the browser or the client directly connects with Azure, the SignalR, which is residing on a server somewhere. So it could be Azure App Service as well. So how Azure SignalR service comes into picture is shown on the other side, where we are saying it's a managed SignalR service. So the browser connects with the SignalR, Azure SignalR, and your app server connects with the Azure SignalR. So there is no direct connection between the client and the server. Azure SignalR service sits in the middle. That's how it allows like as the client scales, it allows those many connections to occur, and also on the server side as well, it makes the scaling possible. So if you look at this diagram, it talks in detail a little bit. So what happens is, for the first time, when the client tries to connect to the server, it makes a negotiate call via the SDKs that you get on the client side. So that call is called as a negotiate call on the server. The server returns a specific address where the client needs to form the persistent connection, and that address is the address of the Azure SignalR service. So client connects with the Azure SignalR service and forms a persistent connection over WebSocket. Likewise, the server also has formed a connection with the with the SignalR service. So now the client and server are connected to each other via the SignalR service, via the persistent connection. So that's how it sits in between. You can place your authentication and authorization stuff in negotiate call and make sure the security is there. So when we set up Azure SignalR service, we set it up either in a default or serverless or classic service mode. So this is a concept in SignalR. The way you deploy it, like when you deploy it, you can either deploy it in default mode or serverless mode or classic mode. So the classic mode is provided for compatibility between default mode and the serverless mode. So it works in both the modes. That is the situation when you have solutions using both the modes and you want to support both of them, you would choose classic mode. But then in default and serverless mode, if you have existing SignalR applications, you'd go into the default mode. And if you're trying to form something new, it's recommended to go the serverless route. We'll talk about what these two different modes are. So default mode is when the SignalR service is connected via the WebSocket on the client side as well as the server side. So it's a persistent connection, and with this connection, you'd be able to have stickiness. Let's say a client is talking to a server via the Azure SignalR service. So next request or the next message that goes in within that persistent connection goes to the same server. Like let's say if you had multiple servers, multiple hubs, the client would be able to go to the same server in this mode. Basically, the stickiness is allowed. So this is similar to what we see in load balancers as well, wherein you have stickiness available. So as I said, this is a good choice if you have already if you need stickiness, if you have already SignalR solutions, this is the default mode wherein you can go in. And if you want to have the server as well, let's say the other mode is serverless, where you don't have a server. But if you have servers where your you have a solution already running, you can use the default mode, and that will allow to basically have the real-time communication. Serverless mode is where you use specifically today Azure functions. In this mode, you can connect So if you look at the changes on the other side where server is connecting with SignalR, you can either connect via webhook, you can connect via REST API, you can connect via WebSocket as well. So all the three different options. In this mode, server does not have to stay alive. In default mode, server has to stay alive. It has to make the connection. In this mode, in serverless mode, the server doesn't have to stay alive. It can it can start when there is traffic. Another thing that happens is here, if you see that webhook, if you see the webhook direction is going towards the server, that means client can communicate to the SignalR service, and SignalR service can be communicated with webhook. So server can be invoked. Like if it is sleeping, it can be invoked and work. If you don't want to form a persistent web connection.
You see the issue of cold start?
With Azure functions? Yeah. No, I haven't seen anything like that. But my applications were always running, so not sure.
With the serverless mode, will there be like a performance impact because the server so might be used in applications which doesn't require this.
So we can use all the capabilities of Azure functions there. If you want to scale based on like the way you set up your Azure, it really depends on how you set up your Azure functions. And Azure function itself has capabilities of scaling based on different demands. Like if you have like if you have spikes, you might go serverless mode. You might go, you can host the Azure's, Azure functions in a web app as well, like the way you want to do it, or containerize it or whatever. But really, it depends on how you want to set it up.
I'm trying to understand. You have put that in the box, right? That server application is that web application which can be in its own function. But your SignalR service will be running in serverless mode, which will be on top of it.
No. Your server application is your Azure function. Where the hub code I was talking about, hub code resides there. The hub code has methods in it which can invoke functions on the client via SignalR service.
So in this case, we don't have to provision a SignalR service.
This is the signal. So here you see the SignalR service. So this hub code resides here. The server wants to talk to the client, right? There are connection issues that we saw in the previous slide, right? So what Azure SignalR service says, you connect with me, and I will forward your messages to the client. That way, you do not have to manage if the number of client increases and the number of connections increases. I am expert at that. Let me handle that. The server is just responsible to communicate with the SignalR service. Now that setup with the server in serverless mode, this setup can be done via these three mechanisms. If you're going from server to SignalR via REST API or WebSocket, or if you're going back from client, let's say a client wants to send a request to the server, then you can invoke it via webhooks. And here your Azure function resides. This is a package, PaaS offering. This is solving a scalability issue, along with that security and other concerns that we have. It's acting as a middleman between the client and the server. All right, demo. I think it will become clearer as we look at the demo as well. So in the demo, I have a hub class here, you can see. So this hub is sitting on the server side. And this part here, I have the client sides as well into the same solution. I have deployed this into a web app on Azure. So the web app has the server side code as well as the client just is separate, but it's separate though. But that's where I have deployed it. So if you look at it here, basically the concept is we are trying to track an aeroplane. So I'll show you the application running directly. I have deployed it. So, and maybe after that, we'll go through the code. That will be easier that way. So this is the application. Right now it's running. I have deployed it. So you see that. So what I've done is like I've downloaded some data of the flight telemetry, and that data is put in a blob storage somewhere. And I'm feeding that data into the like the server is reading that data from the blob, and then basically reading it and then sending those one by one, bit by bit data to the client side on this browser, and then that is being rendered here on the map. And it is
the aeroplane which was moving from one place to another.
Yep.
That was fed through SignalR service.
Yes, this is being fed through SignalR service right now. So server, again, I'll go through it again. I have a data in JSON file which has the telemetry in it, which resides in a blob. The server side application, the server basically takes that blob and reads those readings that it has received in it. And then based on that, every time as the time passes, it sends those reading via SignalR to the SignalR service. The SignalR service is basically passing this to the client, this client. Now, if you go on your phone on this one, on this URL as well, you'd find that here I'm showing you one join. So there's one client. If you go on your phone on in here, you'd see two clients joined. So server is making sure that it is keeping track of who is connecting, and then it will show the messages here, like how many clients at the moment are connected. So it's AZ for Azure user group UG web app dot Azure websites.net. Sorry?
And join, it says to join.
Okay, yeah, looks like to join. Yep. So now you are also getting the telemetry. So you're one of the client, which has so Azure SignalR has connected. So you have made the WebSocket connection with Azure SignalR at the moment.
And I guess you are taking data from blob because it's just demo, but in
world, in real world,
might be transmitting that telemetry.
Exactly. So there are APIs which connect in real time, and you can basically show it. So when you Google and see, maybe they're using behind the scenes SignalR, nobody knows. So real time use case of this.
Someone else also.
Yeah. So with that understanding, we can look at the code. So you see, this is the hub I was talking about, which can connect with the client. So when it is connected, whenever the client is connected, these are the events that are, these are methods being called on the hub. And on connected, on disconnected, when you joined, you saw like one joined, two joined. These methods were called, and what it is doing is calling this update visitors method on client side, on the client side. So what that method does is it just updates that one join, two join, the message that you saw, right? And it keeps track of number of people joined in the control object here. And this control object is nothing but the implementation of flight control, which reads the blob file that I was mentioning about. It reads that when it is instantiated, it reads that data, and basically it has a simple timer here, which is going through the, keeping track of the time. Whenever there is an elapse that happens in milliseconds, it calls the broadcast flights method. What this method does is basically calls an update aircraft method on the client side by sending these details about the telemetry. So these are the time, the speed, and where we are. And this is what the client side function takes in and reads and updates the map in real time. And when it sends it via the hub, basically. So if you look at in here, it is taking the dependency on that hub. So hub provides you with all the underlying code that is required to create that connection with the WebSockets and making sure the connection is persistent across. So that's how it connects. And then on the client side, as if I can show you some of the code in here. like I said, so that is the update visitor one, which just updates the joined message there. And on the client side, we just need to, as I was saying, there are client libraries, client side libraries. This is the library that we are using. This is the JavaScript client. Likewise, there is Java client. There is .NET client. If you had, .NET based client applications, like there is a desktop or anything like that.
So is the hub for good enough to connect the signal?
That is it. Yep. That's what connecting. At the moment, this is what is deployed. This is.
So you don't have, you're running Azure SignalR.
Yes.
Where are you?
Yes. So the Azure SignalR service. So let's go to the portal. Yeah, let's go to the portal. I'll show you those things. All right, in here, you see the SignalR service endpoint value. I don't know what does it. I'll click in here. So you see this here. So SignalR gives you this URL, the endpoint, where the server is making the connection. Since this is the default mode, in the default mode, as we discussed, this application is deployed in default mode. As we discussed in default mode, it forms that WebSocket connection. And this is the endpoint at which it forms it. And yeah, it has its own access key to make sure things are secure. That's how the server knows how to connect. And the client side makes a call to the yeah, I think I just added the Bing API keys here for the map. Yeah, I think I missed it. So when the clients, when we connect on the client side, that index.html renders, and the SignalR service basically, I'm trying to forget. Yeah, I'm blank at the moment. I don't know.
And come back.
Yeah, I think we'll come back to it for sure. I forgot. I'm sorry about that. Yeah, but when you hit on that URL, you're trying to join. The Azure SignalR service intent connects you with the SignalR service. I don't know. I'm trying to find like where it finds that connection from. But that is, so the negotiate call happens, and the negotiate call gives you the connection details from the server. Oh yeah, that's how it happens. I'm speaking it. So basically, when you connect with the web server on that URL that you gave, basically because of the SignalR service, it has that SignalR endpoint. When the negotiate call happens in the first diagram that we saw, the negotiate call happens, these details were exchanged between the client and the SignalR service, and that's how the client forms that connection with the SignalR. So you don't have to explicitly provide it anywhere, because your server itself is giving you the URL that I was talking earlier in that diagram that we saw, where to connect and form the connection. So the client side basically forms that connection that way.
So the configuration that is shown in that app service, that itself was good enough.
Yeah, that itself is good enough, but that is for the server side to connect. And then it takes that itself and gives it to the client when the client tries to connect. And this all happens in that SignalR client side library that we saw. Does that make sense? Yeah. So I was like, why am I not seeing it? It happens under the hood. So yeah. The other things here, yeah, I think we were here at Azure portal, and I was showing. So if you see here what is deployed, so this is the storage blob where my data is residing, which I was talking about, which the server is reading, right? Yeah, the data file here is nothing but simple JSON object, which has which is in the format of that class that we have in here. Flight record class. So in this format, we have in JSON structure, we have it, and then we're just reading it directly. Yep. Yep. And there are some endpoints here. So basically, I can control the speed of that airplane and to start it or restart it or stop it via an API as well. This is an implementation which is not part of SignalR, but part of this demo, wherein you can basically specify the aircraft to start or stop or whatever. Set the speed.
Yeah,
Exactly. That's hard coded, and this is real time. I can go on that, that URL and basically change. So, for example, if you want to, right now the speed is at 1. I can change the speed ups. Change the speed to 10. And then you'd see it moving faster now on your screen if you're seeing it. Yeah, you can see that's flying around like a jet. But
we have a timer there as well, like how fast it's.
So the data file is limited. There's a lot of telemetry data. It's limited, so I have kept it in a loop to fly. And again, this is one disclaimer I think I forgot to mention. This is not my personal demo. This is the demo taken from the Azure SignalR samples directly from our documentation. So you can get it from there and build it on your own. So this is the place I got it from. So I thank you to the community for that. They've created it. Just took me 2 hours to set it up. It's great.
Where did you change the speed?
Yeah, so there is an API that is there's a controller in here. There's the control. Animation controller, right? I'm right on there. So here we have a set speed method. What it does is on the control object that which is controlling everything about that airplane. It sets the speed there. It calls the set speed on that one.
Once you deploy it, you can just make the API call.
Yeah, you can make the API call. It calls this endpoint, and it sets the and that control. It sets the speed, and that right now that this dependency is a singleton here. So you have one instance of it running, so you can change in the way the demo works. But yeah, this is not something for real life. This is more for demo. But that shows us the different parts of it, right? The hub, the client, how they could connect with each other, and how basically SignalR comes into picture. So if you look at SignalR now specifically, Just wanted to go back to Azure portal. Yeah, so that was one part, and this is the Azure web app is where it is deployed. The API is deployed there. The client-side code index.html is residing there. The hub is also residing on this web. So if you remember, this is the default mode. Now this is the server, and if we go back, look at the SignalR service. Yeah, so this is the SignalR service that is running. If you look at the connections, we saw increase here somewhere just now, right? We saw some increase in here, and the message count. So these are the messages, like you see 1.6K messages. That is the data from that blob. It's continuously running, and see that much of data.
Can you change the mode default to serverless?
Good question. I think we can do that, but it has its own complications. I think if you look at here, choose default mode when all hub cells. 30 seconds to take that effect. We can change it, but you might have the downtime and might have to see the consequences. I haven't looked into the details on that, but then again.
Yeah, that's good. At least if we start with default, if we want to switch to serverless.
But yeah, I'm thinking here. So if you see there is a fundamental difference between how it communicates in both the modes. So in serverless mode, everything is like server can disconnect and stay back. But in default mode, if you go back from server to default, I think that's very difficult because the server has to stay up. The server has to make the connection first, and then only the clients can connect in default mode. But in serverless mode, everything is okay.
So if we click on save, will that break your code?
Good thing. Now we have seen it, we can break it.
Because in some of the services, if you try to change the tier of the service, they don't allow it. You have to create a new instance of the service, which is sometimes pain. They allow you to do it in single levels.
It looks like it allowed me, but I'm not sure if it worked. So it's working.
This way,
Yeah.
can work.
I think reverse will
not.
Reverse, yeah, because the way it communicates fundamentally changes, right?
I
Like
think
when
it's
you go
also
back.
because it was set up in such a way that that's why it worked. With write a hub which will work with serverless and you switch to default.
So if you write a hub specific to serverless.
Yeah.
You switch to default, it might.
Yeah, it's not gonna, because at that point in time, you're changing the fundamental thing where the server has to stay up, right? And in this case, like as you move to serverless, the server can stay up or go down, it doesn't matter.
I think if your hub is written such a way like it communicates with the SignalR with SKP or something.
Yeah.
Then you start to go back.
Yeah. And then the implementation of serverless are mostly with Azure functions. The reason behind that is because it itself is serverless. You don't need it, right? Like you don't need the server. That's why it's Azure functions is the default choice for it, because you don't need the server to be maintained. Right? But it doesn't mean that really, you cannot have a server. So yeah, let's go back to the presentation real quick here. After the demo, I'd like to show some of the architecture diagrams here, which I took from the documentation. So if you look at it there, this is the IoT based application where oh, sorry. Oops. All right. So this is the IoT based application. So the major part here is from Azure function onwards. Anything before Azure functions can depend on what kind of domain you are in and what kind of applications you have. But after Azure Functions, things remain mostly same in many solutions. So first thing that happens is client is trying to connect with Azure Functions. Azure Functions, you'll have a function with negotiate endpoint. That's the first thing happens. When the client tries to connect to the server, negotiation happens. So you can have a Azure function and have negotiate endpoint there. And then you can provide the details of Azure SignalR service, the connection string of Azure SignalR service as a return, a response to the client, basically. So that's the first thing happens. Once the client gets that Azure SignalR endpoint, it basically connects with that service. That's the number 2 there you see in the diagram. That's how it forms the connection there. And then as you see on number 3, as on the device kind of send that data, those go through the Azure function, and then Azure function is connected with SignalR service, and then hence the messages go to the clients there. This is how the typical flow in the serverless mode as well. As I said, like the right hand side of the equation stays almost same no matter what different solution you have when you go to the serverless mode. So here we have like the tracking. Azure Service Bus is in play here. There is direct integration available, right, with Azure Functions and Service Bus. And also in the serverless, there are bindings available for connecting with the SignalR service with Azure Functions. So you have direct out of the box, connectivity that if you want, you don't have to code anything explicitly. You have bindings available. So that connection is way easier. In a matter of couple of hours, you're up and running.
Find my location. There's an app, right?
What is it?
It's called Find My, where you can track GPS
Yeah.
devices.
Yeah.
Does that use a SignalR?
I don't know. As I said, there's a competition in this space.
Pretty similar to what yours.
Yeah, there are a lot of real life usages, and yeah, we'll see that as well. Like I have some highlighted in this presentation as well. Yeah.
I use it for notifications.
Okay. Yep, real-time notifications is another thing. We have used it in past in our projects where we used to send it the notification. The thing was that scaling was never an issue in some of the projects that I worked with, and Vaibhav and Santosh, I worked together on those projects. So it was easy. We didn't need this. So SignalR old way was working for us. But today it's all about scale. Well-architected framework. Yeah, well, everybody in this room would be aware about this well-architected framework. We have one for AWS as well. Why I bring it here in Azure SignalR services, because we want to put the lens of well-architected framework and look at some of the capabilities that allow or support these different pillars, and thus help us form the well-architected solution when we use SignalR service, right? The 5 pillars here we see, if you're not familiar, should be, the solution should have less cost, better security, should be reliable, operational excellence, such as you should have observability in place, it should be easier to work with it, and performance efficiency in terms of scaling, latency, and all that stuff should be taken care of. Then we say like you have a well-architected solution. Again, it depends, as in the architecture world. In terms of security, all the Azure's, the basic things that is being provided into all of its services are available here as well, like the key-based rotations. You have managed identity. It also supports the Azure, backplane, like private endpoints as well. Like if you have devices in the private network and you want to communicate securely with the web server, you'd be able to do that, set up the VPN and have your devices connected and talking over a private endpoint rather than the public network. So that is also available. You can also you can also control who connects and with your you can stop the server side connections. You can, allow through the network access control here. Um, yeah, and that is the security part. And as I think one thing which I did not mention in there is like you can implement the authentication authorization related stuff into your the negotiate endpoint that you saw in the Azure serverless mode, or any of the communications that happen between the server and the client. So you can implement those as well. So the one implementation that we have done, like I had worked on projects, we had done it with Azure functions, and then we added all the, whenever the client requests, we want to make sure that we know that client, and then only we pass on the SignalR service details,
So if
server
some
details.
client is setting your SignalR, assume that negotiation went successful and the user is authenticated.
Yes,
That
without
only-
without
only you'll have is return the SignalR URL, otherwise.
otherwise it's not. So right now this demo was on public network, so you were able to connect. But if it was not, then it would ask you to log
If you
in.
had authentication. and
Yeah.
authorization.
Yep. So on the performance efficiency side, scaling. So let me take you back to the portal here for a moment. Those things are best seen in the portal, I think. So you can scale up or out. When you want to scale up, you have these options available. This is basically mainly the limitations, the physical limitations of how the service is offered. So everything is considered in units, basically. So every tier here gives you certain number of units. So if you see the largest unit is differing in every service layer, and each unit has certain number of connections that are you can have. So for example, here you can have 1 million per unit per day. Sorry.
What is it?
Yeah, unit is the measurement of so units are through which you scale. In one unit, there are certain number of connections that you can have, certain number of messages that you can have.
Is it
And then-
similar to have some instance? Like how many instances you can have with anyone?
Like you have DTUs, right? Like
DTUs.
yeah, it's a form through which they measure and allow you to scale, and right. So it's that unit basically. So they call it as unit. Unit as a
Because app services have similar limitation as you creating.
Yeah.
Premium, you can have certain number of instances within them. So
Yeah. So this is the way how you deal with the physical limitations of the world, right? Like they put it in a measurement criteria and then allow you to scale based on that and bill you accordingly as well, right? So you see here, the billing as well is different for it. I think I have included that in there.
Snowflake.
Uh-huh.
Well,
No, I haven't.
they have something I think might be similar. And they kind of just price stuff in like small, medium, large, extra large. And, but it's so easy to wrap your head around, right? As opposed to trying to go to like GCP or something.
Yeah.
And try and figure out the pricing. So I'm guessing that's what the units is like.
Yeah, I'd say more or like it allows you to think in terms of what your application needs. Let's say, for example, if I don't need like I'm good with 20,000 messages a day, and that means I'm good with one unit, right? And let's say my message range is around here, the connection ranges are in here, and this is what I look for, right? So 100 units. So if let's say if you have your number of clients, they are increasing and decreasing seasonally. You can choose one of the tier here. Let's say if you're choosing this one, number of units available to you are 100, and your application can scale. Let's say today you need 10, tomorrow 20, come back to 10, go to 80, come back to 10. Really, depending on, you can scale on that basically. So I think it will be easier if you look at the scale out side of it. But I brought this up to, yeah, this is my Indian subscription. So I'll show in my slide. It's $60 per month or something like that. But yeah, but here you see that auto scaling.
It's an Indian because I just saw that. Always gonna use $4,000 of that.
Yeah, this is my old subscription. So yeah, you can see that in the premium tier, you can have the ability to auto scale, and that's important. I think that's why you'll pay for it. And some of the security features as well.
I think that's where your well-architected framework goes into place, because I've seen development teams who will go ahead and provision premium queues for their non-prod and dev environment. Where you don't need auto scaling.
Yeah, we don't need those things. Exactly.
So you can save your cost by running in free or standard queue.
Exactly. Yeah. Yeah. So if you go look at the scale out, we should be able to see that we can scale two ways. Either you can scale manual, and you see let me go to manual for a minute here. You see units here. This is what the scaling basis. So if you go to custom scale, you would be able to scale on matrix or specific units. So if you go specific, like if you go matrix and add a rule, you'll be able to see that we have different matrix available here based on which you can scale. Let's say your connection count increases. That means your clients are increasing, or your server side is also increasing, both side of connections. And that's why your one unit may not be able to serve it well. And you might experience the connection drop issues, scalability issues right there. So here you can just specify the percentages as usual, the Azure way.
My cost to run one unit or 100.
What is it?
Does it impact my cost?
Yes.
The number of units are there?
No, once you are in a tier, you have 100 units, let's say, and you'll be paid. Let's say you are having 2 units you're using out of 100, you'll be paying that much based on
units or 400.
So you'll be paying what you are which tier you are in basically, and it will scale based on the number of available units that you have in that tier. Yeah, and as I was saying, like these are different things. So this is the major thing that that you have to pay attention when it comes to using Azure service, and you have scaling in needs. Then this is the place you have to pay attention more, because rest everything is piece of cake. I think this is the place where you have to understand what is the traffic of your application, and what are the different factors through on which you should put the scaling rules. So for example, if your application has bigger message sizes, that increases the count, as well as there are some limitations on the message side, like the message size cannot be greater than certain limit. I'll have to refer to the documentation on that, but then that kind of impacts your performance of the application, and also you might see some issues in terms of the connection drops or not being able to connect. You might see those issues. So you have to carefully design the message size at the same time when you're designing the solution, and look at really what you are seeing here, because the message count will increase, the inbound and outbound traffic or bandwidth will increase if your message sizes are big. So it's not always just the traffic. It might be the way you're the size of your message as well, and that will cause the impact with the performances. So this is the only piece which I find which is the critical piece where when it comes to designing these applications. So that's the scaling part. And as we saw in the security side, we have identity, managed identity provided. We also saw the network side and the private endpoint being available. One thing which I wanted to show is on the monitoring side, we have the metrics, alerts, all the Azure way of doing things. But then there's something called live tracing. The live tracing allows you to basically see the telemetry, like what is being communicated at the moment. This acts as a client, and subscribes to all those Azure SignalR service as a connection. And then it shows you all the messages that are going in. So let's say if I'm here, I'm not sure if it will work right now because we had if I refresh it.
So not ready on
What is it?
the bottom left, it says not ready.
Oh yeah. Yeah, maybe we'll have to come back to it. But then here we can see all the messages, all the events that are happening in live. It is not recommended to run it in production, but only because it has performance applications. We can come in and see a like turn it on, see something, and then go back and turn it off. But yeah, you have log analytics workspace, right? You can always push all your logs into the log analytics workspace and have it have all this information collected in the log analytics workspace and analyze it for analytical purposes. So that's what on the scaling side, performance efficiency, we just saw that. These are the metrics that we saw. Reliability, how do you bring that in, right? So what if your service which is running in the primary region down? You'll have to think about either setting it in another region, or maybe you can set in the same region multiple primaries. So what I mean by that is, let's look at the diagram first here on the left-hand side. The way it is set up is in each region, you have Azure SignalR service on the left-hand side. The right-hand side is your server. So when the client connects first, let's say it's connecting to the East US, it gives the URL that I was talking about of SignalR service, which is hosted into the same region that acts as the primary SignalR service. And then the client connects with it. But in case that region goes down, then you have the other regions also set up this way. Like you have in West, you have a SignalR setup acting as a secondary. And then you have the web server over there acting as a secondary. Here as well, like for redundancy needs. So in case the East US goes down, and when the client connects with the server in the East US region, the server gives you the secondary endpoint because the primary is down.
So negotiation happens once a day.
So no, the negotiation happens only once because the web server is up, the SignalR is down. Like if the SignalR service is down, the cloud here shows the SignalR basically.
At negotiation, it returns 3 different URLs.
So it will return just the secondary URL where, so this is the primary, this is secondary, and you can configure in your web application, like which of these three is your secondary and which one is primary.
What if my client is already?
What if what?
My client already negotiated and it's trying to win.
Good question. I'll come back to that. So first here, like in this flow, what happens is the client is connecting with the primary app server. It detects that the SignalR is down. It detects it because there is heartbeat sent to this SignalR service and make sure that his SignalR service is connected with the server. And if that is not the case, it's going to give the secondary URL, and then basically client will connect to the second SignalR service, and thus it will work. But let's say now it comes back. In that case, if the primary SignalR service comes back up, in that case, if the client is already connected to the secondary, it does not go to the primary again. It goes to the primary only when the connection is dropped and the client again sends a negotiate request to the app.
And this is the connection.
What is it?
Sticky connection.
I don't think so. This is because your primary server is down. I mean, it happens. It is the same behavior in both default mode and serverless mode. It's the same behavior in both. So your primary is down. It sends you to the secondary. But once the connection is formed, it does not have a way to know that, unless it is needed. So once the connection can be dropped if the client closes the browser in the web applications. And then as soon as the connection is dropped, either by closing the browser or in some cases, the connection times out. In those cases, the connection drops. and then negotiate call again happens, and this time because the primary is up, it will give you the
And
primary.
just the same case would be when it's connected to West US and West US goes down.
Exactly the same
Connection will
place.
drop and it will again move.
Exactly. The same thing happens there. So this way you'll be able to manage your user base globally as well if you have multi-region needs. This can be done in the same region also if you want to have multiple primaries, even that is a possibility. And you can always set up like where do you want to route your traffic to by returning the correct URL from whenever the client tries to get the negotiate call, tries to make the negotiate call. That way you'll be able to manage it as well. So that's how you bring in reliability also into the picture, and redundancy and whatnot, the disaster recovery, all those things. Cost wise, here is that US dollar. So you see here, I think 46.66 US dollar per month per unit in that tier. So if you are increasing to the scaling, if you're using 2 units, you'll be using $100.
100 units, but if we have selected only 10, we'll pay for
exactly
46 by 10. by
Exactly.
10.
Depending on what is your scale, the number of units you're using per unit, that is the cost. So I have used it for 2000 messages per minute, right? Somewhere around it goes for that traffic, that much traffic, it goes around somewhere around four units up and down at different times. $500, $600. Within $600, your solution is working for around 20,000. No, I think 100,000 devices. Yeah, the best part is that with this less cost, you don't have to maintain the scaling needs of your server side. You don't have to worry about your client base increasing, and it's all managed for you. And you have SDKs available, support available on this. So best
The
use of
challenge
money.
with well-architected framework is that we want to go with reliability and scalability and performance. Your cost will never be down.
Exactly. That's the
It's always
that's
a
true.
trade-off between 4 pillars versus.
And then how will Microsoft earn money then?
You can run in free tier, but you will not get any of those free. So if you start assuming those, your cost will start.
Yeah.
So that's why they don't say cost. They call it cost optimization. They don't call it cheapest or.
Yeah, and I think it makes sense as well. And the cost part of it really depends on solution to solution basis, right? If you have really high traffic and it's worth it, you're getting millions of dollars on that, or billions of dollars out of it. It's worth it to spend that much money on it, right? So
And
I think it's a
auto scaling comes in really handy in cost optimization.
exactly, because that pulls the load off of your team, right? And frees your team to basically do other stuff. I think I went through this, the log analytics workspace, live tracing. Let's see if it does come up. Yeah, I think it's broke, but then, yeah,
I think you
it
did
does.
not enable it.
Did I not? Oh, that's the reason. I didn't save. Sorry, that save button, we always miss it. Yeah, I think it should come in now. Yeah, we'll come back to it maybe. Yeah, there we go. You see all the telemetry is coming in. You also see the connection ID. So each client has a unique connection ID that it forms. So it does tell the IP address as well. Yep. So you can see it here, what's going on. Some of the performance considerations, as I was earlier mentioning, you have when you're designing, you have to make sure you understand the message size. You design it that way that it's not costly for you or not performant. Keep it small, and also you have to look at the message rate and the limitations I showed on the unit size, like what are the physical limitations. Also, you may have to stand up the another primary in case your current primary is not able to meet the scale. You have to make all those decisions when you're trying to consider the performance. And so look at the number of connection means your number of clients, your client base. You have to look at all those different things. And it's, I think, in my opinion, it's all case to case basis and see really what fits best. But these are some of the points you want to take care as you're designing the solutions. Platform support, we have as server side, as I was saying, anything that ASP.NET Core supports, SignalR supports that. Windows, Linux, Mac OS. On the client side, you have JavaScript client, .NET client, Java client as well. And those are supported clients by Microsoft. And then there are unsupported ones are C++ and Swift. Swift is for iOS. Browser, these are the browsers which are supported. Mobile support so these are the different client side libraries that you can use for these respective platforms. So Android, Java clients can be used for Android side. Swift can be for iOS. Xamarin has its own package. Flutter, which is used for mobile applications, it has SignalR Flutter package that you can use. React Native work on JavaScript client. Some of the best practices. So it's again, if when you're designing the applications, as I was mentioning earlier, if you think about those design like the message size, consider the message size, it's the message rate frequency. Also, you might see that the connection gets dropped because WebSocket by nature is designed for speed, and it's not that reliable. The connections might drop. When they drop, you have to make sure that you are exiting gracefully, and for that you might put in the graceful shutdown through either that on disconnect. On the server side, we saw that on disconnect on hub method available on server side. You can manage server side from there. Likewise, on the client side also, you can manage things for your graceful shutdowns. Also, because you're using Azure, you might use Azure Functions for serverless. That's from cost perspective, it's great. Authentication, authorization, keep that in from security perspective. Look at those monitoring tools. Basically, the monitoring the monitoring tools available, like the diagnostic tools, and also those matrices that are available to basically take the corrective actions and steer it well. You'd be able to use the retry policies as well, right, for connection management. Yeah, some advantages of using SignalR service. It is standard-based, has global scalability that we've seen. It is managed for us, cross-platform compatibility. It is secure, cost-effective, and it's very easy to integrate with Azure ecosystem. As you saw, if you're connecting with Azure Functions itself, it gives you a lot of other connectivity options. Also, Event Grid is also compatible with this one, so you'd be able to easily integrate with Event Grids. Yeah, we've seen that there is support for persistent connection in terms of web sockets. The serverless option is what we've seen via the Azure Functions. High availability, redundancy. We have seen how we can achieve that with the cross-regional setup that I showed earlier. It improves the developer productivity as well, because you have SDKs available, you have support available, and SignalR is a technology we've been using, like we have used it in past, and it's being offered as a service now. So it makes it more easier than it was. Some real world application. Just these are some of the last slides that I have. I just wanted to make you leave thinking about these real world applications where you might use SignalR in your next project. Is like gaming, voting, polling, auctions, stock markets. Yeah. That's a big thing in the documentation I saw, like they're promoting SignalR very well for that. Dashboard is the, the stock market, financial stuff, observability side, IoT related monitoring, chat box, chat side as well, because it has broadcasting capabilities as well. And then location tracking, we saw the demo as well on that one. Oh, there are targeted ads as well. I think in that space as well, we are using SignalR because it has the capability of tracking the user actions as well.
Everybody using that.
These collaborative apps that we work nowadays is in demand, like those diagramming, yeah, is Mira board and whatnot, right? The push notifications, which we've been using since many years for SignalR, IoT side and automation, in terms of like how you connect with other Azure services, basically. So yeah, that is what it is. Any questions?
So I want to ask a question, just a general question. How to, so there is some cases that we need to use message queues, and there is some cases that we need to use like something like WebSocket or SignalR. Is there a way that make me easily determine which way to go?
Yeah. So where SignalR shines, I think I'm sorry, I was not able to deliver this message, but SignalR where it shines is communicating with the client. So in disconnected mode, so for example, you saw here that a client and server, when server wants to communicate back with the client, with the queue has to, like, queue has a different space, like it has a different place in architecture where you want to use it for different reasons, real-time messaging, scaling, whatnot. There are different reasons for it. But SignalR is specifically used for connecting with the client's back. And it does it so well over the WebSocket, and it is built for real-time fast communication, where queues and whatever we use in different tools like RabbitMQ, the exchanges, those are for different purposes. But having said that, in this presentation, I did talk about Azure, Amazon SNS, and the other slides that you might have seen in the front. I'm not very familiar with those technologies, but they are in the real world as well, offering some of the needs, but really not what the SignalR offers in terms of connecting with the client. There is one more service in Azure called PubSub service, Azure PubSub service. That is very close to what SignalR offers. But again, it should be used when you do not have any SignalR related needs, and your solution are interacting with the queue-based offerings. So if you go and read about it a little bit in the documentation, you'd know that those are the cases when you want to use the Azure PubSub service. SignalR is used because traditionally in many applications, people have used SignalR for this kind of communication where the server wants to communicate with the client. Let's say one of the projects which we worked on, we had some long running process that, let's say, when user clicks on a button, it creates a process. Behind the scene, it runs and creates a report. And when you're trying to send that message back to the client, who initiated the request, you'd be able to basically connect that back with that client and send the request. So that capability was not offered previously, like in 10 years before in many other technologies, right? SignalR was there. So that is the reason SignalR exists, I believe, today as well, because now you want to make sure those solutions are also catered to. Yeah.
General question.
Yeah.
SignalR actually stand.
SignalR, real-time signals, I think. I'm guessing that. I think the R stands for that only. It's real time.
Short for real time.
Yeah. Microsoft. Yes.
Thanks, Sunil.
Thank you.
Thank you.
Thank you, everybody. Happy holidays. Thank you so much.